What does it really mean for an AI to think? Today, we're diving deep into why ASP.NET Core defines modern .NET interviews. ASP.NET Core is the high-performance, cross-platform web framework powering cloud-native applications, microservices, and APIs at scale. It underpins containerized deployments, serverless architectures, and real-time systems at Microsoft, Stack Overflow, and millions of enterprises. Technical interviews now test architectural depth, how the pipeline works, how DI is scoped, how configuration flows. Fluency in these concepts differentiates senior candidates from those limited to surface-level implementation. The framework's Kestrel server, open-source runtime, and modular design make it the default for new .NET projects. But here's where it gets interesting. Problem: surface knowledge fails under scrutiny. Candidates list middleware names but falter when asked about execution order or short-circuiting. They register services without distinguishing cloped from singleton lifetimes. Configuration sources and the options pattern remain black boxes. This gap is exposed when interviewers present a request tracing scenario without a system view. Answers collapse. The pattern stalls careers and caps growth at mid-level roles. So what's the real problem? Let's talk about cause. Framework treated as a black box. Learning paths emphasize scaffolding over internal mechanics. Developers memorize steps without visualizing the host, pipeline, or service container. The generic host, WebApplication.CreateBuilder, and middleware order remain unexplored abstractions. Projects work initially without deep understanding, masking the knowledge debt until interviews or production incidents force confrontation. This gap compounds as applications scale and complexity increases. This raises a critical question. Breakthrough, architecture-first mental model. Shift from rote memorization to a composable mental model of the request processing system. This model covers host initialization, service collection, middleware chain, endpoint routing execution. Each component becomes a configurable stage with clear responsibilities and ordering constraints. Adopting this framework enables reasoning about any scenario debugging, extending the pipeline, designing new features. In interviews, it transforms answers from recitations into architectural walkthroughs that signal engineering maturity. Now let's zoom in on system, hosting, and startup architecture. The Web Application Builder orchestrates bootstrapping, setting configuration sources, JSON, env, secrets, logging providers, and the service collection. The generic host abstracts the web server Kestrel by default, also IIS, http.sys. Service registration defines the application graph, DI container, middleware endpoints. Startup is deterministic. Understanding this sequence enables full customization. Interviewers probe this flow. How does program.cs build the app? How do environment-specific configurations apply? Here's something most people overlook. Components, the middleware pipeline. Middleware forms a bidirectional chain. Incoming, each delegate can process, modify, or short-circuit. Outgoing, response passes back through each. Critical ordering, exception handling, CRS, authentication, authorization, routing, endpoints. Branching with map-when enables sub-pipelines for different routes. Custom middleware injects cross-cutting concerns like logging, header validation, or throttling. Proficiency means predicting and manipulating exactly how a request traverses the pipeline. Think about this for a second. Components, routing, and endpoints. Endpoint routing separates URL matching from dispatching. The routing middleware selects an endpoint based on patterns, constraints, and metadata. Endpoints resolve to MVC controllers, razor pages, minimal APIs, or custom delegates. Route templates support defaults, constraints, .kid, .tot, and transformers. Endpoint metadata carries authorization policies, CRH rules, and output caching directives. Interview questions test URL to action mapping, fallback logic, and versioning strategies. And this is where things get complex. Components. Dependency injection and configuration. The built-in DI container resolves services through constructor injection, enabling clean dependency graphs, lifetimes, transient, clobed, Singleton govern creation and disposal scoped, aligns with request scope, configuration is composable, providers JSON, NV, CLI, key vault, layer, and override in order. The options pattern, iOptions snapshot.art binds configuration to typed classes with validation. Mastery proves a candidate can design testable, maintainable services. But here's where it gets interesting. Workflow, full request lifecycle. Kestrel accepts a connection and creates an handshake. Middleware executes in order, exception handler static files, CARC's authentication authorization, endpoint routing, endpoint execution, controller, minimal API, etc. At each stage, services resolve from the correct scope. Logging captures events. The endpoint produces a response which flows back through middleware in reverse for post-processing. Completion, logging. Walking through this lifecycle demonstrates genuine system comprehension. So what's the real problem? Let's talk about impact. High signal interview performance. Architecture first answers elevate the conversation from what to how and why. Discussing scoping decisions, middleware order trade-offs, and configuration precedents reveals real-world engineering judgment. Interviewers recognize a candidate who can design and debug production systems, not just complete tickets. This perception accelerates hiring decisions, increases salary offers, and opens senior and staff-level roles. The systematic mental model becomes a career multiplier. This raises a critical question: future, .NET 9 and the evolving interview. .NET 9 pushes native AOT for faster cold starts and lower memory, critical in serverless and edge. Interviews will probe AOT limitations and benefits. Blazor United merges server and client rendering. Minimal APIs evolve with native OpenAPI support. .NET Aspire provides a cloud-native application model with orchestration, service discovery, and telemetry. Expect questions on performance optimization, observability, and microservice resilience patterns. Staying current with these shifts maintains competitive advantage. Now let's zoom in on preparation framework. 5 domains to master. Hosting, generic host, web application, server selection, environment handling. Middleware pipeline, ordering, short-circuiting, custom middleware, error handling. Dependency injection, lifetimes, registration strategies, service validation, scopes, configuration, providers, options pattern, secrets management, reload on change. Performance, Kestrel tuning, asyncs await, caching, compression, minimal API optimizations. Build a visual mental model. Practice tracing requests. Articulate architectural decisions clearly. This preparation yields high-impact interviews.